Hello guys, today we're going to try and understand how the multiplexers work. So I just want you to look at this ugly circuit and compare with this. So now I want you to look at these two circuits. Which one do you think is more optimized? Which one do you think is more cost effective? And which one do you think is going to give you less stress? Of course is the one in blue. And that one in blue is called the multiplexer. So that is the usual logical shape of the multiplexer. And anything you see on the left hand side or the longest side is going to be your data inputs, and this is going to be your control input, and this is going to be your output. We usually call it Z. So here we have I0, I1, I2, and I3, and we have A and B down here. So in this multiplexer we have two input variables, which are A and B, and from the combination of A and B we can make four different combinations, which are 0 0, 0 1, 1 0, and 1 1. So let's try making a table out of this. And if you notice, these four different combinations that A and B produces correlates with the four data inputs we have. So 0 0 is going to correlate with I0, 0 1 is going to correlate with I1, 1 0 is going to correlate with I2, and 1 1 is going to correlate with I3. So the best way of seeing this is just like binary numbers. We know that 0 0 is 0, we know that 0 1 is 1, we know that 1 0 is 2, and we know that 1 1 is 3. And that is the subscript we use for the I values, just to make things very easy for us. What the multiplexer does is that it just chooses one value. So let's try seeing the skeleton of this multiplexer. So this end of skeleton is going to show you what really happens, because in the multiplexer we need one of these four values to pass through and get to Z. So it's only one of these four values that's going to survive, and it's going to be determined by the control inputs, which is A and B in this case. We have A and B. So for the control inputs, let's say A is 0 and B is 0. Z is going to directly go to I0, because that's the only thing that it matches with among these combinations. So now let's say our A is 0 and B is 1. That correlates to I1. And in that case, Z is going to configure itself to I1 here. And any information in I1 is going to go to Z. And if A was 1 and B was 0, Z is just going to connect itself to I2. And any information from I2 is going to come down to Z. Same thing for I3. So that's all that happens in the multiplexer. We don't want to be using a bunch of AND gates and OR gates when we know that we can just use the multiplexer in order to get like some certain values. Hopefully this shows the basic understanding of the multiplexers. We have different type of multiplexers. We have the 2-to-1 multiplexer, and in this example I showed you the 4-to-1 multiplexer. We also have the 8-to-1 multiplexer. The same concept is used in the 2-to-1 multiplexer. We have just A, and A just has two values, which are 0 and 1, and that correlates with the I0 and I1. And for the 8-to-1 multiplexer, we find out that we have A, B, and C, and if we make a table for that, we find out that we have 8 possible combinations. And that in return correlates with the number of data inputs we have. And the same thing goes for the 2-to-1 multiplexer. In this case we just have A and then Z, which gives birth to I0 and I1. I'm sure during the course of this video you were finding something strikingly similar, and that is the number of combinations of your control inputs is the same as your number of data inputs. So to sum it all up, we can say that n control inputs give rise to 2 raised to the n data inputs. And you see, this makes sense, because 2 raised to the power of 2 gives you 4, right? And 2 raised to the power of 1 gives you 2, and 2 raised to the power of 3 gives you 8. And to get the equations of multiplexers, it's good you have it in the tabular form, because that way it's going to make your life a whole lot easier. I want you to know that when a is equal to 0 is the same thing as a prime. And also when a is equal to 1 is this just the same thing as a. Right now, let's look at the first row of the table, which is a equals 0, and that is the same thing as a prime, like I told you. B equals 0, the same thing as b prime, and we have I0. Plus, the plus signifies the transition to the next row. A equals 0, the same a prime. B equal 1, so it's not going to be b prime, it's going to be b now. Then we have I1. Plus, a equal 1 now, so that's just going to be a. We have b equals 0, that is b prime. And we have I2. Plus, we have a equal 1 now, which is just going to be a. B equal 1, which is just going to be b. And we have z equal I3. So this signifies the equation of the 4-to-1 multiplexer. And I'm sure finding the equation of the 2-to-1 multiplexer and the 8-to-1 multiplexer is going to be easy if you just follow the steps I showed below. So hopefully this tutorial helped you guys in understanding multiplexers and how it makes our life a whole lot easier when it comes to computing binary numbers. If you have any questions or you have any topics that's of concern to you, please leave your suggestion in the comment section below. I hope you guys have a nice day, and that's a smiley face for all of you guys. Peace.